Good morning. This is a shorter video today, but it's kind of the overview of Chapter 13. I'm going to do a few example problems in 13.4, and then we'll give you the review problems to work on. We will have a Zoom meeting the next class to go through all the review problems, and then we have a quiz at the end of the week. Look on PowerSchool for the information. All right, so in 13.4, we talked about the different ways to calculate interest depending on how often it's compounded. The equations you will be given, you just need to know how to use them. So these are story problems, and similar to story problems that we've done throughout this chapter, we end up graphing two graphs and we look for the intersection. So this problem says the principal amount, P, earns this interest, R, compounded continuously. Find when the value reaches 1800. So the compound continuously equation is what I call the PERT equation. So the first thing we're going to graph is the exponential growth equation for this. So the value at any time t will be $350 e to the 0.06 t. This is what's going to go in y1. Y2 is when will that reach 1800? So what we've always done is we've graphed a horizontal line at the value we're interested in, and then we look for the intersection. So I'm going to graph this 350 e to the 0.06 t, or x in this case, and I'm going to graph 1800. Now remember, the key here is the window. Right, so I need to know when it gets to 1800. So I'm going to use this. I'm going to say y min, I'll take y from 0 to 2000. Now x min, I'll put at 0. I'm just going to guess. Wow, we're asking for a lot of growth here. We're at 350. We're taking it times 6. So I'm going to put my x max at like 50 because I don't have a clue. So I'm going to put 0 to 50, and then on the y's it'll be 0 to 2000. Now I'm going to see if I see my intersection. If I don't, well, it looks like I'm going to see my intersection. Yeah, so 50 was plenty because it comes up and we see the intersection here. So now let's find that intersection. Second trace, go down to intersect. First graph, yes. Second graph, yes. Guess. All right, so my intersection says this, which means at 27.3 years, my investment will be $1,800. So this theme of graphing two equations, this happens in every story problem we've done in this chapter, right? We're going to graph the growth or the decay function, and then we graph, most of the time, a horizontal line and look for the intersection. There could be a time where we graph two growth functions and we see where they intersect, but we'll talk about that. The next one says, all right, now it gives us the answer too, so we'll see if we're close. So a person invests $1,800, that's my P, that earns this interest, annual interest. This is once a year. Find when the value reaches 3,500. So the once a year equation is the simple one that looks like this. So the first growth equation, principal of 1800, 1 plus 0.0246 to the t. Second equation is that horizontal line. When will it reach 3,500? All right, so y goes from 1800 to 3,500. So why don't I make the y min like 1,500? And why don't I make the y max like 4,000? All right, and I don't know about x, so I'm going to say maybe 0 to 20. So I'm going to come down here, clear and clear. All right, so the first one is 1,800, 1 raised to the x. Second one is 3,500. Oops, I didn't change my window, so I'm going to have a problem.